Hello again, guys, and welcome to the next lesson. In this one, we're going to go over deductive reasoning. Now, if you remember from the very first lesson, we talked about inductive reasoning, and I kind of gave you a little hint about deductive reasoning. Well, in this PowerPoint, we're going to go over deductive reasoning in depth, because we'll be using this one a lot in the upcoming chapter. Before we move on, I do want to say, make sure you have the classwork out. It is Investigation 2.4. It is Investigation 2.4. Now, I know this slide says to complete the investigation, but if you haven't done that, it's fine. You can do it throughout the video. And with that, let's get started. Now, inductive versus deductive reasoning. Okay. When we went over inductive reasoning last time, we talked about how inductive reasoning uses patterns or examples or observations to make a conjecture. Okay, you were drawing a guess. Basically, you're making a guess after observing something. And I think the example I used in class was, if you see the trash guy come every Tuesday, if you walk out of your house on Tuesday, you're going to guess the trash guy is coming. Okay, because you've seen him do it every single day. And here's another example. Okay, every game, Katie wears her favorite socks to a softball game, and she makes at least one hit. Katie is wearing her favorite socks to tonight's game, so she concludes she'll make at least one hit. So the pattern is that when she wears her socks, she gets a hit. So she thinks because she's wearing these socks, she's going to make another hit. Patterns to conclusion. Now, deductive reasoning is different. I think I described it to you last time as Sherlock Holmes. All right, you use facts, rules, definitions, properties to reach a logical conclusion from given statements. Okay, so whereas with inductive reasoning, you observe the patterns and you observe the examples, and then after observation, you make a conjecture, you make your educated guess. Deductive reasoning is different. Deductive reasoning is you start with something you know to be true, and then you take another step which you know to be true, and then another step which you know to be true, and you keep doing that until you end up with a conclusion that you know to be true. Okay, so all deductive conclusions are considered logically true because of the process I just explained. Okay, if you start with truth and you keep going with truth, then you should end up with truth. And there is another example down here at the bottom. So if John is late making his car payments, then he will be assessed a late fee of $50. John's payment is late this month, so he concludes he will be assessed a late fee of $50. Okay, so we start with the fact that if he's late, then he gets a late fee. Then when he is late, he gets a late fee. That's just the way the rule works. This is deductive reasoning. Now, deductive reasoning has two laws. Okay, these laws are the laws of detachment and syllogism. This is on the top section of your worksheet. So if you already completed the worksheet before the lesson, excellent. If not, pause the video, look in the book, and find the definitions and write them down. Go ahead and pause the video. And welcome back. We'll go over law of attachment first, and then law of syllogism. All right, so law of attachment. This one states that if P then Q is true, and P is true, then Q must be true. Okay, so law of attachment starts off with an if-then statement, and then it tells you that P is true. And therefore, since P is true, because of our if-then statement, Q must also be true. And I'll give you an extra example. So in the example that I made up, it goes, if your room is clean, then your mom will give you your phone back. A situation I'm sure none of you have gone through. So you have this rule. If you clean your room, then your mom will give you your phone back. I then add this extra piece of information. You cleaned your room. logically, because our statement says, if you clean your room, this is our hypothesis, you cleaned your room, then the conclusion, if that happens, is that you'll get your phone back. So since I told you the hypothesis happened, P was true, then Q must also be true, and you should be getting your phone back. Okay? So detachment, you start off with an if-then statement. You're told the hypothesis is true, and then therefore the conclusion must also be true. Now, the law of syllogism is slightly different. This one goes, if P then Q and Q then R are true, then P then R is true. This one is almost like the transitive property, but for statements. And if you've forgotten, the transitive property is A equals B, B equals C, then A equals C. Okay, now normally this would apply to numbers, but the law of syllogism says it applies to logical statements as well. Let's look at the example. If you do your homework, then you pass the final. If you pass the final, I will have a B in the course. Conclusion, if I do my homework, I will have a B in the course. Okay? So our first statement is right here. If I do my homework, then I'll pass the final. That's this first one. Then the next one is, if I pass the final, I will have a B in the course, and that's this next one. Then your conclusion is the first part of the first section, so if I do my homework, and the second part of the second section. I will have a B in the course. If I do my homework, I will have a B in the course. Now, the trick for law of syllogism is Q. Notice how Q is in both pieces. You have P, then Q, and then you have Q, then R. Here's how you can tell if the law of syllogism is logically sound, and that's if you have Q in both statements. So to show you in this statement, it's if I do my homework, then I'll pass the final. I will pass the final is Q. That needs to be the first part of the next statement. And it is. If I pass the final, then I have a B in the course. Since Q repeats like this, we have law of syllogism, and it is logically sound. So that's law of attachment and law of syllogism. If you want to add these examples onto the classwork you have or in your notes, it'd be an excellent idea. And let's move on. All right, so these examples are on the classwork that you have. You can go ahead and pause the video and try to answer them for yourself. And here are the answers. So check and see how you did. If you got one wrong, try to look at the example and then try to look at the definitions I gave you in the last slide and see why you got them wrong. If you're still confused after everyone has finished the video, please ask a classmate to see if they can explain it to you. If not, ask the sub. All right, and let's keep going. Now, when we had inductive reasoning, okay, that was patterns and then a conjecture. We talked a lot about coming up with a counterexample to prove the conjecture false or invalid. Well, with law of attachment, again, you can have invalid deductions, but instead of there being a counterexample, what there is there's a flaw in the logic. So one of the statements doesn't follow like it should. Now up here at the top, I have the two laws for your convenience, but make sure these are in your notes. You can study later. So let's look at this bottom one. Now it is invalid. See if you can write down underneath why it's invalid. And here we go. If a figure is a square, then it's a polygon. Figure A is a polygon. Therefore, I conclude that figure A is a square. Pause the video and see if you can figure out why it's invalid. And welcome back. Now, this example would be law of detachment, except for that it doesn't say the hypothesis is true. Figure A is a polygon is part of the conclusion. If you look up at the law of detachment, if P then Q is true and P is true. So you have to be told the hypothesis is correct. If you're told that Q is correct, well, you don't know where Q came from. It could have come from anything. All right, given the example down here at the bottom, there are a lot of polygons. Figure A doesn't have to be a square for it to be a polygon. Okay, so for law of attachment, you have to be told that P is true, otherwise the statement is invalid. Okay, basically you can't go backwards. You can't go from conclusion to hypothesis. You can only go forward, and you can only say it's true if the hypothesis is true. Let's try another one. Again, the top bit is given to you for your convenience, but what I want you to do is pause the video and figure out why this one is invalid. And go for it. And welcome back. Now in this one, it would have been law of syllogism, except for the fact that if you read carefully, the statement says, if a figure is a square, then it's a rectangle. If a figure is a square, then it has 4 congruent sides. The piece of information that repeats in this example is if a figure is a square. So that is the P of the first statement. However, if you look up at the rule, the law, it is Q that has to repeat. Okay? It is the conclusion of the first statement that has to be the hypothesis of the next. Not the hypothesis is the same for both statements. And it doesn't matter that a rectangle does have 4 sides. Okay? This little word congruent makes that false. Okay, a rectangle doesn't have 4 congruent sides, it just has 4 sides. So you have, in order for law of syllogism to be true, it is the conclusion of the first that must repeat as the hypothesis of the first. And that is all I have for you today. Please make sure you have these examples written down in your notes and that you have completed the worksheet with the definitions and put the worksheet in your notes. All right, I will see you next time. Bye, guys.